Hi, I'm Chloe. In this video, I want to show you a production-ready AI chatbot I built for e-commerce and customer support using RAG, FastAPI, n8n, and Telegram. This is not a simple ChatGPT wrapper. It retrieves real product data, keeps conversation memory, and handles purchase follow-ups. Let me show you what that exactly looks like.
Let's open the chat on Telegram. Say hi. Hi there, how can I assist you today? Okay, I'm looking for hydration cream and I have sensitive skin. It's wonderful that you're seeking a hydrating cream, especially with sensitive skin. Here are two fantastic options from the ordinary that could be perfect for you. The first one, natural moisturizing factors with beta glucan, with price, short description, and you can find it here, which provide an URL. You can click inside and see the official website. The second one, natural moisturizing factors with HA, also with price and URL, and simple routine, safety guidance, perfect. Okay, I want to buy the second one. Okay, the second one is natural moisturizing factors with HA. The chatbot will provide you the URL. You click inside, you see the natural moisturizing factor with HA, perfect. And the more detailed product description from the official website. And you can add it to the cart further. Okay, and I want a cleanser for oily skin. Absolutely, for oily skin, it's important to choose a cleanser. Okay, also with two options, with price, URL, simple routine, safety guidance, perfect. You can also see this on the n8n side. Let's open the n8n workflow here. You can see that the chatbot's answer is built directly from the retrieved products. You can also see the product's details coming from the vector database, like the product name, title, category, price, and URL. So this isn't a guess. The chatbot is answering based on the data it actually retrieved from the vector database. And as you saw just now, I didn't have to repeat myself. The bot understands what the second one refers to, and it replies with the correct product's price and official link. This is exactly the kind of behavior you want in a real shopping or support flow. Now let me show you how I actually made this work under the hood. To make this work reliably, I had to be very strict about how data is stored and how the model is allowed to answer. All the product data comes from the Ordinary's official website. I collected myself and stored it in a vector database using Python. I used two data sources on purpose because they serve different roles. Structured JSON files give me reliable feeds like product name, category, exact price, and the official URL. And the knowledge markdown documents give me richer context, longer description, users' details, and better support for more open-ended questions. During the ingestion, I'm also very careful about how the data is chunked. Each chunk is tied to one single product, so the product name, price, and URL always stay together. This avoids common RAG problems like missing prices between products or losing important metadata during retrieval. On top of that, I enforce strict rules at the system level. In the system message, I defined hard constraints. The model is only allowed to answer using data retrieved from my own knowledge base, either the JSON metadata or the markdown documents. If a price or an official URL is missing, the model is explicitly instructed to say no found in the knowledge base instead of guessing. So even at the prompt level, the model is not allowed to invent any product or price. On the backend, the logic is also clearly separated. One part handles retrieval, another part handles intent detection, like purchase intent or price follow-up intent. and a separate layer formats the final response. So when a user says something like the second one or what's the price, the system doesn't ask the language models to figure it out. Use explicit function to trace which product the user is referring to, extract the exact price from JSON metadata, and return only verified fields. The model never invents products or prices because it can only work with data that was actually retrieved from my pipeline. So the behavior you saw earlier is completely driven by code and data, not guesswork. That's what happens inside the backend. Now let me zoom out and show you how everything is connected in n8n. The flow itself is pretty straightforward. A user sends a message on Telegram. n8n captures that message and extracts the text and user ID, then sends it as an HTTP request to my FastAPI backend. Inside the backend, the Python code runs the RAG pipeline. It retrieves relevant product data from PyCom, applies intent logic like purchase intent or price follow-ups, and builds a structured response. That response is sent back to n8n as raw JSON, and n8n delivers it back to the user on Telegram. One reason I like using n8n is that it runs 24/7 on the cloud. Once the workflow is published, everything keeps working even if my laptop is off. The other reason is visibility. With n8n, I have full visibility into the data flow, from incoming messages to backend requests and raw responses. Let's open the HTTP request. You can see the raw response coming back from my backend. Each recommended product includes the name, price, and URL, as well as metadata like the data source, namespace, and version. This proves the chatbot isn't generating answers on the fly. You can literally see which products were retrieved, where they came from, and exactly what data the model is allowed it to use. So it's very easy to chase and verify the data flow. On the backend side, everything is deployed on a Linux server. I'm running this on Hasner Cloud, which is a lightweight and reliable setup. The API is built with FastAPI and managed using systemd. So the service runs continuously and restarts automatically if anything goes wrong. In production, there's no hot reload, which means conversation memory stays stable, and the service doesn't randomly reset. Once it's deployed, the whole system just stays online. Even if my laptop is off, the chatbot keeps running and responding to users 24/7.
So to sum it up, this chatbot is built around real product data. It retrieves verified prices and links, keeps conversation context, and handles follow-up intent like buying or pricing correctly. This kind of setup works especially well for e-commerce or any system where accuracy really matters. If this is interesting to you, feel free to reach out.